Okay, lesson 7.9, we're going to be factoring the special products. So if you recall, in lesson 7.4, you were introduced to the special products patterns. So we had this sum and difference pattern over here, and when we were first multiplying them, we noticed that when we had this pattern, the middle term canceled out, and so we were left with a squared minus b squared. Well, now that we're factoring them, we're going in the reverse direction. We're going to take it from this form back to the two binomials. So we're basically, what we want to do is take the square root of the first term and the square root of the second term. So we have square root of x squared is x, square root of 9 is 3. So we would put it in two binomials, x plus 3, x minus 3. So the sum and the difference, okay? Looking at these, the way we did it in 7.4 is we went from this part and we got to this, right? Instead of having to, you could draw it out, right? We could make this a plus b and a plus b, and we could have foiled it or whatever. But, or we could say, oh, okay, that's a special trinomial pattern, and we could come up with this. Well, now looking at the reverse, we have a trinomial, and we notice that this is a perfect square and this is a perfect square. If you can take the middle term divided by 2 and get the square root of that c, right? The square root of 9 is 3, and 6 divided by 2 is 3, then you know that you have the special pattern. And so it would become, and these are two addition, so x plus 3 squared in factored form. Here in 7.4, we went this way. Now we're going in reverse. So we have the subtraction and addition, but 6 divided by 2 is 3, square root of 9 is 3, two perfect squares for bookends. So we have this x minus 3 squared. So we're going to first take a look at the difference of 2 squared, and then we'll do the trinomial pattern in the examples to follow. All right, so if we're looking at the difference of 2 squares, right here, okay, we know, and here's a better idea, is to look here. So we're going to, the product of these is right here. So if we want to factor it back to its pieces, to its binomial pieces, looking at this, it's kind of like we're taking the square root of this and the square root of this, and we have, x plus 3, x minus 3. So since the square root of 9 is 3, and the square root of 1 is 1x, or 1x squared is 1x, we would get x plus 3 and times x minus 3. So let's do a couple of those. So again, we want to take the square root here, so we know we're going to have x and x. Square root of 25 is 5, so we'll have a positive 5 and a negative 5. For part B, again, when you take the square root of this, you're going to get 2z. So inside, we get the 2z here and the 2z here, and then you get plus 1 minus 1 because the square root of 1 is 1. So it's real easy to do. So we're going to look for this, and we know that we're going to have s and s, and here the square root of 49 is 7. So because this is a difference of two squares, we will have plus 7 and minus 7. Okay, so there's no middle term, right? This is a binomial, no middle term. We know that it had to look like that originally. So we have t plus 9, t minus 9. So we're factoring these. Now this you can keep in this order. So we could do 4 plus x and 4 minus x. That's fine, that we don't have to rearrange the terms. And here, so we have, inside these parentheses. And so we're going to take the square, the square root of 4g would be 2g. So I want to start with 2g. And the square root of 25 is 5, so I'll have a plus 5 and a minus 5. All right, why don't you go ahead and do number 5. Give me the factored form for number 5, and I'll work with this one. So we'll have two binomials right here. Square root of 81 is 9, right, because 9 and 9 is 81. And then we'll have square root of 49 is 7, so plus 7k and minus 7k. And that shouldn't matter that the order's a little different. Okay. Now, looking at this, right? We started out with this, and we knew that there would be two positives here. Note that A is a square, right, the first term, and this C term, which they have labeled B here because of the algebraic notation, but if we look at, I guess if we look at the example right here, this is a perfect square and this is a perfect square. When the two, like the bookends, the two ends are perfect squares, we could go take the square root of this and the square root of the 9 and write it like this in it's factored. We know that, right? And if it's two positives, it's a plus sign. If it's two negatives, it's a minus sign. Okay. So, you know, and this being a trinomial with a leading coefficient of 1, half the time you're probably not even going to check that this is the case. And you may start to do it and say like, okay, I'm looking for factors of 16 that will sum to 8. Well, it's 4. 4 and 4, you get the same thing. They're both positive, so you're going to get like, you know, n plus 4 and n plus 4. But you can simplify that and write it like this, if that's the case. All right? Same thing here, you know, doing the rainbow method and finding, you know, factors of 36 that will sum to a negative 12 and then factor by grouping. But look how easy this is. Since we see that this is a perfect square and this is a perfect square, we could go right to the fact this is minus and this is plus to here. We know that the square root of 4x squared is 2x and the square root of 9 is 3. And this could be like a shortcut for you. So that's what we're trying to help you see these patterns in the math. So let's try several of these. So again, when I do these, I'm always looking for something that I can factor out, nothing that I can factor out. Then I look to see if there's any perfect squares. There are. This is a perfect square. This is a perfect square. So I would get x plus 8 quantity squared in factored form. It's that simple. Okay. You do have to know and, you know, practice. You can use your calculator to find your square roots. You could always retry it to make sure it goes back to this trinomial. For 14, again, both positive, and in this case, the square root of 196 is 14, so we have p plus 14 quantity squared. Okay, when you have the negative here, we're going to have the square root of 169, so we'll have r, and then we'll have minus square root of 169 is 13 quantity squared in factored form. So I'm just kind of reversing that pattern, and all I'm doing is taking the square root of the first term and making that the first term, the square root of the last term, making that this term, and separating it with a subtraction. Okay, why don't you do number 16? Write the factored form of number 16. And number 17, I can see that this is a perfect square and this is a perfect square, both positives. So in the first place right here, A, I have 6c times 6c would give me 36c squared. 7 times 7 gives me 49. So I can factor it pretty easily by identifying the first and last term as perfect squares. Here, perfect square. So we'll get 10x minus 1 in this case because of this subtraction right here. So hopefully you found that this is pretty straightforward and easy. We'll keep working on these. All right, solving the polynomial equation. So now we're going to do the same thing. We're going to factor it. School's out. And then we're going to solve for x. So we've been doing this quite a lot as well. So looking at this, I can see it's a difference, it's a difference of two squares right here. So when I factor it, I will get x plus 12, x minus 12 equal to 0. So we have x is equal to negative 12 or x is equal to 12. This is not equal to 0, so I want to subtract 49 first from both sides. So 9y squared minus 49 is equal to 0. Both are perfect squares. Difference of two squares. So here we have 3y, and then this would be 7. So plus 7 and 3y minus 7 equal to 0. Now, if one of these has to be equal to 0,
On this first one, we're taking 3y plus 7 equal to 0, so we're subtracting 7 and dividing by 3. So y would be equal to negative 7 thirds. Here we're adding 7 and dividing by 3, so positive 7 thirds. Okay, why don't you solve number 21? And I'll keep going. So here, remember the coefficient is 1, so it's a perfect square, and the pattern is going to be, we want d minus 2 quantity squared is equal to 0. And this just means we have a double factor, just like you did in number 21. So d minus 2 is equal to 0, or d minus 2 is equal to 0. So d is equal to 2. We really only have one choice of the matter, or one solution for this. Notice that we haven't really had to worry about the middle terms in any of these special products. So let's look at this one. We want to rearrange it. So we will add 1/9 to both sides. So n squared plus 2/3 n plus 1/9 would be equal to 0. This is a perfect square because you can have 1/3 squared. All right, so there's two positives, so we'll have n plus 1/3 quantity squared is equal to 0. So when we solve, we're subtracting the 1/3 from both sides. So negative 1/3 is our solution, and again, we only have one solution. Okay, last one. Let's put this in descending order. So when I add k squared here to both sides, I want to go ahead and put that in the front. So k squared minus 6 over 5k plus 9 over 25. And again, this is going to be 3/5 when I take the square root. Because of the subtraction, I have k minus 3 over 5 quantity squared. So when I add 3/5 to both sides, I'm going to get k is equal to 3 over 5 as my solution. Okay, so on this problem, so we have the dimensions of a rectangular prism are x plus 1, x plus 2, and 4 by 4. This must be the height. So this would be like the length and the width and the height. Okay, the volume is given as 24x minus 1. So I'm going to try my best to draw a rectangular prism. I'm really not that good at it. But I know that, like, say this is the front face here, then this would also connect to each of the others, so we have all those faces around. So we have this, x plus 1, we have over here x plus 2, and when they're talking about the height, let me change colors real quick. They're talking about this altitude right here. So the height then, say, is 4. Okay. So we know that we have the volume, so the volume is equal to the area of the base times the height. So that would be, in this case, the volume is 24x minus 1. The area of the base would be length times width, x plus 1, x plus 2, and then times, the height. And that's going to be, in this case, 4. So we just go ahead and multiply over here. So 24x minus 1 is going to be equal to, your first term would be x squared plus 2x plus x plus 2, and then all of that would be times 4. So 24x minus 1 equals x squared plus 3x, doesn't look like a 3, but it is, plus 2, and that's, now we can distribute the 4. So we have 4x squared plus 12x plus 8. Now we need to make it equal to 0 to solve for x. So we're adding 1 to the constant. We are subtracting 24x from the like term. So we'll get 0 is equal to 4x squared minus 12x plus 9. Perfect square, perfect square. So we have 0 is equal to 2x, because the square root of 4x squared is 2x, square root of 9, and then this is the pattern with the subtraction, so 2x minus 3 quantity squared. So when we solve this, we only have to solve it once for x, and finding the value of x answers the question. We would be adding 3 and dividing by 2. So x is equal to positive 3 over 2. All right? If I went too fast or you need any more explanations, be sure to ask for help in class.
Okay, the vocabulary and concept check for lesson 7.9. Please select one that you would like to respond to, identify it, and use complete sentences. If you have any questions, please let me know, and I will see you in class tomorrow. Have a great night.